Hey everybody, Dr. A here, and in this video we're going to be exploring an example of computing the centroid of an area using the integral formulation. But before we get started, don't forget to hit like and subscribe and be on the lookout for other content like this. Okay, let's dive into it now.
And being asked to compute the coordinates of the centroid of the area. Now, if you look at this figure, this is very much like something we've seen before. In this case, the area is going to be this shaded area up here. So it's the top half triangle here, not the bottom half. And we're given the equation of this line right here is obviously it's h over b times x. Okay, hopefully you can clearly see that. So how do we go about calculating the centroid of this area? Well, same process as before. We have x bar equals integral x tilde dA over integral dA, and then of course we have y bar equals integral y tilde dA divided by integral of dA. So same process as before. However, you have to look at each of these problems in a slightly unique way. All right. So if this is our shaded area, here's what we have to do. We have to look at what is dA, right? So if this is the shaded area, dA is this little slice right here. Don't just memorize that dA is always going to be y times dx. That may not be the case, okay? You have to look at each type of problem in a unique way, all right? So in this particular case, based on where the area is, you have to look at a slice right here, okay? This is your dA, and so this dimension is still dx, okay? It still has a width of dx. But what is the height of this area, right? What is the height of this differential area right here? So let's talk about that. Let's write this off to the side. dA is going to be something times dx, okay? It's going to equal something times dx. Well, it's not y, okay? Because if you think from mathematics point of view, what is y? Y is the height from the x-axis up to a function, okay? But that's not what we have. We have this height, right? We have the height from the function up to like an upper bound of sorts, all right? So what would that height be? Well, it would just be h minus y, okay? Take a look at that. This is h minus y. How in the world am I getting that? Well, again, if I want this height right here, then if the total height is h, and I have this equation here that has a height of h over b times x, then I just say total height h minus y, okay? So if that's h minus y, then that's the same thing as saying h minus h over b times x. So that's how I'm going to piece together my dA. Okay, so here's my dA, h minus h over b times x dx. Okay, so there's my dA, and then I'm going to have to also look carefully at my x tilde and y tilde as I move forward. Okay, so I can just go ahead and maybe check off these dAs because I have it now. But the work is you're going to have to think critically and figure out what is x tilde and what is y tilde. So let's come down here. Let's say determine x tilde and y tilde. All right. So I'm going to redraw this. Again, I've said it before. Take time, redraw these things so you understand what you're doing. Okay. So here's B. Here's H. And here's that shaded area that I'm interested in. All right, so let's look at a slice. Okay, let's look at a slice right here. Where on this is my x tilde going to be? Well, x tilde is measured. Remember, x tilde is the moment arm from y axis to centroid of dA. So my x tilde is right here. Okay, that's x tilde. Okay, so very similar to what we've seen before. If this is x tilde, then we're pretty much done, right? Because x tilde, the center line of this slice, you could slide this dimension line down here, and this right here is your x tilde still. So x tilde is still just going to be x. Okay, similar to what we've seen in another example. What about y tilde? What about y tilde? Well, again, y tilde, same definition, moment arm from x-axis to centroid of dA. So it's the moment arm from the x-axis to the centroid of dA. So this is y tilde. How do we get that? Take a second, maybe pause the video and see if you can figure out how do we determine an expression to get y tilde. And remember, this slice dA could be over here somewhere, right? And so in that case, we would look for a y tilde like this. So we need some kind of formulation for it. It's not just a number, it's a formulation. All right, so maybe you've thought about it. Maybe you've paused the video to think about it. So let's talk about it. So the first thing I can kind of recognize is that I know this distance. Okay, I know this. I know the height of dA, right? So we're gonna say the height of dA is what? It's h minus y. Okay, we figured that out earlier, right? So it's scroll down just a little bit. The height of dA is capital H minus y, which is capital H minus h over bx. Okay, now if y tilde is going to the middle of dA, right? If y tilde is going to the middle of dA, then what can I say that is equal to? Well, that's going to be half of this height plus distance y. Okay, so maybe draw this out a little bigger over here. Okay. All right, so this distance right here, that's y. Okay, so that's like this right here, and I know this distance, right? That's h minus h over bx all divided by 2. How do I know that? Well, again, the height of that slice is h minus h over b times x. So if I want half of that height, I just take h minus h over b times x, divide by 2, okay? But I need the moment arm all the way down to the x-axis. That's down here. So I have to add to it y right here. And what is y? Y is my function, okay? So y, of course, is still h over b times x. So I'm going to say y tilde is what? It's h minus h over b x divided by 2 plus h over b times x, okay? So that's kind of a looks a little messy, but that's okay. We can combine a lot of like terms. We can combine this as h over 2 minus hx over 2b plus hx over b. Okay, and so once we have this, let's see what we can combine. We can get y tilde as we have these two like terms with x, don't we? So we can say that this is h over 2 plus hx over 2b. There we go. And that's our y tilde, okay? That's our y tilde right here. So now we have everything we need to piece this together, okay? So now we can say x bar is equal to the integral 0 to b. We're still integrating with respect to dx, so it's 0 to b. X times h over b x dx divided by integral 0 to b h over bx dx. And oh, I'm sorry. Back up. I was thinking about the previous example. It's h minus h over bx dx. H minus h over bx dx. There we go. Okay. So, yeah, because remember dA is right here. H minus h over bx dx. Okay. So here's our integral for x bar, and we can evaluate this, right? We can evaluate this, and then let's go ahead and just do that now. So we're gonna say we've got the integral from 0 to b of hx minus h over bx squared dx divided by integral 0 to b h minus h over bx dx. X bar is a pretty simple integral to evaluate. So we got hx squared over 2 minus hx cubed over 3b evaluated from 0 to b divided by hx minus hx squared over 2b evaluated from 0 to b. And we can substitute some values in. We get hb squared over 2 minus hb cubed over 3b divided by hb minus hb squared over 2b. And let's see how we can combine some terms here and cancel some things. We can cancel this b with one of these b's. We can cancel this b with one of these b's. So a lot of algebra here, so just be careful. hb squared over 2 minus hb squared over 3 divided by hb minus hb over 2. And we can get some common denominators and combine some terms, so that numerator becomes hb squared over 6. The denominator flips and becomes 2 over HB. I'm just letting you know I skipped some algebra steps right here. So maybe you do some algebra to go from this step to this step, but I skipped maybe 2 algebra steps in this step right here. So you guys figure that out, okay? And when we punch this through, we end up with just b over 3, okay? Just b over 3. So that's my x bar. And then I'm going to do something similar to y bar. I'm going to do something similar with y bar. And so we're going to say y bar is equal to the integral from 0 to b y tilde dA. So where's my y tilde? Or don't forget, that was the tricky one, right? Y tilde is right here. So my y tilde is going to be h over 2 plus hx over 2b, and then my dA comes from h minus h over bx dx, all divided by integral 0 to b of h minus h over bx dx. And I would FOIL this out, okay? I would FOIL out before you take the integral, right? So before integrating. You should know how to do all of this from pre-calculus and calculus 1, okay? And so evaluating this, I'm not going to show all the steps here because it's algebra and you should be able to do this on your own. So you do end up getting 2h over 3 as y bar. And so if you wanted to sketch out that area, here it is. Here's y. Here's H, here's B, and Y bar again is going to be about right here. Y bar is 2H over 3, and then X bar was B over 3, so it's about right